Okay, well, it looks like the uh, the logins have slowed down here a little bit, so we're three past the hour. So I'm going to go ahead and get started. If you missed something, we are recording today, so hopefully any folks coming on a little bit late will be able to catch up. My name is Jacob Serfling. I'm one of the co-directors of the Midwest Building Decarbonization Coalition, and this is our Building Decarb 101 training. We try to offer this every few months or so, just to get new folks to the coalition more acquainted with the topic and how we talk about it here at MWBDC. So we're glad you were able to join us. Like I said, we are recording today, and we try to keep a fairly up-to-date version of this training up on our website in the past training section. So if after going through this, you think this would be good information for somebody else in your network to see, feel free to direct them to that video. We want this to be a resource for people out there in the world to make this topic as accessible as it can be for folks. If this is your first time at a MWBDC event or one of our trainings, just a quick overview of the coalition. Our overall mission is to develop and implement equitable strategies to achieve zero emissions from the Midwest building sector by 2050, and we'll get a little bit into what that means and why that's important here over the course of this training. And we have 8 priority states that we primarily work in. We have coalition members that are based outside of those states or are national in nature. But in terms of the work that we do as a group, we're primarily focused on Minnesota, Iowa, Missouri, Wisconsin, Illinois, Michigan, Indiana, and Ohio. As I said at the top, my name is Jacob Serfling. I'm one of 2 co-directors of the coalition. Prior to stepping into this role, I was a HVAC and energy efficiency engineer for around a decade, and I'm based in Des Moines, Iowa. Our other 2 full-time staff members at the coalition are Marnice Jackson, based in Pontiac, Michigan. She's the other coalition co-director. And our communications manager, Maggie Heiser, based out of Columbus, Ohio. All right, so let's get into Building Decarbonization 101. We're going to start with defining a few building decarb terms and breaking down all the aspects of that. Then we'll kind of run through why this is a key climate inequity issue in our region. And then we'll wrap up by going through some of the challenges that we're trying to tackle as a coalition. And a lot of the sections of this presentation could be blown out more in depth and be their whole own training, and sometimes they are here at MWBDC. So this is just meant to be a little bit of a high-level overview to the topic for everybody. So I think the first question we have when we have new folks coming in is, well, what even is decarbonization, or what do we feel like it means as an organization? So we would define it as converting any of the energy using activities that we are engaged in as humans, from utilizing burning of fossil fuels to provide that energy, to converting it to some sort of clean carbon-free source. And a lot of places that study energy use in this country will kind of break down that into 3 main end use buckets that are easy to think about in terms of what we do that uses energy. So the first being transportation, cars, planes, trains, and things of that nature. The second is industrial processes, so manufacturing or refining of materials, where we're utilizing energy to engage in those industrial processes. And then the third big one is commercial and residential buildings, and that's the one that we are focused on as a coalition. So the energy we use to make our homes and workplaces usable and comfortable. right? And then on top of those main three, there's kind of this fourth subcategory, maybe you'd call it, of electricity generation. So we know that some of the energy that's delivered to transportation and industry and our buildings comes in the form of electricity. And sometimes that electricity is coming from clean carbon-free sources. Sometimes it's coming from power plants that are deriving energy from burning fossil fuels, converting it to electricity, and then delivering it somewhere else. So that's decarbonization in general. When we're talking specifically about building decarbonization, there are three main aspects to that, and they are all equally important in terms of the three things that we need to do to make sure that buildings are being supplied energy in a clean, carbon-free way. Those are energy efficiency, electrification, and then finally carbon-free energy generation. And we'll talk a little bit more about what all of those things entail as well. So the easiest way that I found to kind of explain those three aspects of building decarb to folks is sort of repurposing the three R's, right? I think a lot of us grew up with reduce, reuse, recycle when we were talking about materials waste. So the new three R's for building decarbonization are reduce, replace, renewables. So reduce, that's that energy efficiency piece, right? We're talking about limiting the amount of energy that the building even needs to perform its duties to keep us safe and comfortable. So that's limiting the amount of heating and cooling that even needs to be provided to the building, or the amount of energy that those pieces of equipment need to perform their work. And second R, replace, that's that electrification piece. And that's replacing the appliances and pieces of equipment in buildings that are currently utilizing fossil fuels in many cases, burning them right at the building site, and replacing them with a version of that equipment that can run on electricity. So we're primarily talking about things like stoves, water heaters, furnaces, or boilers. And then that last R, renewables, that's that carbon-free energy generation piece. That's saying once on top of reducing the amount of energy the building needs in the first place, and making sure that everything in the building that needs energy can utilize electricity as a form of energy, that the electricity being delivered to the building is coming from some sort of clean, carbon-free source, whether that be derived at the building site or from somewhere else. It's not utilizing fossil fuel burning at any point in that chain. So we can dig a little bit deeper into what all of those aspects even mean, or what are some of the specific tools or tactics that we're using to accomplish those three pieces. So let's look at that energy efficiency or reduce piece first. What we're primarily advocating for to happen in buildings are upgrades to the building envelope. So things like building weatherization, sealing those air gaps and things like that, utilizing higher performance insulation in windows in new construction, or swapping out older, less well insulated versions of that in existing building retrofits. And that's really the key piece in minimizing that amount of heating and cooling that the building needs in the first place. Energy efficiency also would entail utilizing higher efficiency heating and cooling equipment, right? So utilizing an appliance that can provide the same amount of heat or cooling to the building with less energy utilized as the technology improves in a lot of these cases. It can mean utilizing heat recovery technology that, when we're ventilating our buildings and bringing in fresh outside air, we're recycling some of that conditioned heat or cooling that we already have in the building and applying it to the new fresh air coming in, so it doesn't all have to come from the heating and cooling system. We're not wasting as much of the energy that we've already used. It can mean utilizing smart controls in the building to make sure that we're not utilizing heating and cooling when we're needing it. So thinking about things like programmable or smart thermostats that can recognize when folks aren't in the building, and it can allow the building to heat up or cool down a little bit more than it would need to maintain comfort when somebody's actually there. And then as we move forward, it can mean more grid connected appliances as well. So things that recognize when there is more clean electricity available to the building, and shifting things that don't have to happen at a specific time to take advantage of that. So thinking of things like our water heater that can heat up that water at any time potentially, and saying, well, we're going to now do that later in the evening when there's less demand for electricity, and we can provide more of that from clean energy sources. And second, let's dig into what we mean on that second R, that replace phase or electrification. And really this hinges on a few main areas where we want to move on from older forms of technology that serve our buildings and move into these new electrified ones. So the key technology here is heat pumps, and we'll talk a little bit more about what they are in the future or in a little bit. But swapping out for space heating and cooling our furnaces, our cooling only air conditioning units, our gas boilers, and replacing them with some form of heat pump to provide that heating and cooling to the building instead in an electrified and efficient way. We're also talking about utilizing heat pumps for water heaters instead of having a burner that heats up the water in a tank, utilizing a heat pump to heat up that water instead. Another key aspect of this replace or electrification piece has to do with cooking equipment. Many homes and commercial kitchens obviously are utilizing a gas range stovetop or a gas oven. We want to start replacing those pieces of cooking equipment with things like induction stoves that utilize magnets, electromagnets, to heat up your pan or pot that you're cooking in instead of having a burner underneath it. And so it can provide the same level of control over your cooking in a more efficient way, moving to other electric cooking equipment as well. We'll talk a little bit about why that's a key component here as well. And then any other things that might utilize gas or propane in your home as well. So some folks have, a gas clothes dryer or things like that. And in pretty much all of those cases, there is a new electrified and efficient technology that can take those things place. I mentioned before that we maybe want to dig a little bit more into what a heat pump is, since that's kind of the crux of that electrification piece, and making sure that folks understand what that means. So a heat pump is a technology that we use to move energy that already exists somewhere else, or move heat that already exists somebody else and put it where we want it to go, as opposed to burning a fuel or running an electric coil to create new heat. So the easiest way to kind of think about what they are and how they work is to think of an air conditioner or a refrigerator that can run in reverse, right? So what is your air conditioner doing? It's forcing heat in your home to move outside, even when the outside of your home is warmer than what your house is, and you're utilizing electricity to do that. So a heat pump does that in reverse, right? It's taking the heat that exists in the outside air, even on a cold winter day, and it's moving that inside the house. And because you're moving heat and not creating it, you can provide the same level of comfort and maintain the same temperatures inside the home while utilizing much less energy. Same thing with a heat pump water heater. Instead of having a burner supplying it to the tank, what that heat pump water heater is doing is it's taking heat that already exists in your basement or your utility closet or your garage, and it's pulling that into the water to heat it up. And so in doing that, it can utilize far less energy, and it can do it with electricity instead of propane or natural gas. So there's a lot of different varieties of heat pumps that exist. The most common is what we would call an air source heat pump. And like I said, that's one that's pulling that heat from the outside air around it. So it's going to have an outside mechanical component that looks a lot like the air conditioner box that already sits outside of most of your homes. But instead of just only being used to reject heat from your house to the outside, it can also, like I said, run in reverse and pull that in. But there are other varieties of heat pump that can pull that heat from other sources. So the other one that most folks maybe know about are the ones that pull heat that's available underground and utilizes that. A ground source or geothermal heat pump is what you'll commonly heard those referred to. And they are very efficient, and there's advantages to utilizing those. And we'll also see heat pumps that can take advantage of other forms of waste heat that's available. So you'll see that implemented in things like water treatment systems or data centers or things like that, where there's constantly a large amount of heat created in those, and utilizing a heat pump to move that heat somewhere where it might be useful instead of just letting it all go to waste outside the building. And then finally, that last R, that renewables or that carbon-free energy piece, what can that possibly entail on a building by building basis? So that might be clean electricity that's generated at the building site, such as a rooftop solar system. That might mean ensuring that electricity that you're purchasing from a utility or somewhere else is coming from a clean source. So, utility scale solar or wind projects, or making sure that the building is supplied by some sort of community solar system. It doesn't necessarily have to all be at the building site in all cases. That can mean utilizing battery technology to bank clean electricity from solar or wind when it's more available, and utilizing that stored electrical energy to provide energy to the building, even when those renewable sources aren't as active. And it can also mean delivering non-electric forms of clean energy to the building. A really exciting concept that we've seen in different parts of the country is this idea of a thermal energy network. So these are cases where individual buildings have their own heat pump, but a joint networked system of wells is what's providing that heat that those heat pumps are deriving from. So it doesn't necessarily have to be electricity that's being delivered to the building, as long as that energy that's being delivered doesn't involve the burning of fossil fuels. And I'm just going to pause. I see that we had one question here in the chat, and I'll quick pick that up while we got it. And the question of, why are the air source heat pumps more popular, and are they more efficient or less expensive? And I think the main reason that they are the most common one we see is that they are usually the most upfront, cost-effective option in most individual building cases. So that they ground source heat pump systems, especially if you're paying for them on an individual building by building basis can be prohibitively expensive for a lot of folks, whereas air source heat pumps are well less efficient, are more affordable, and still more efficient than their fossil fuel counterparts. But that's part of why some of these technologies like thermal networks are so exciting, because they would let more folks take advantage of that really efficient geothermal technology without having to eat all of that cost of digging a well and all of that themselves. It would be shared across more folks, and then become more cost effective that way. And yeah, if folks have questions as I go, please put them in the chat or the Q&A, even if we just pick them up at the end. Happy to do that here. Okay, I'm going to quick take a sip of water, and then we'll get into why we've formed a whole coalition around this question of building decarbonization. So why buildings? Of all the climate and environmental justice issues and sources of emissions and pollution that we could talk about, why the specific focus on buildings? So nationally, if you look at the data from the Department of Energy, we know that in any given year, typically commercial and residential buildings together account for around 30 to 40% of US CO2 emissions. So they're a really critical thing in general. And we know that that share of emissions goes up as you move into colder climates in more densely populated areas, which is certainly a large portion of the Midwest. And then specifically in the Midwest, if we look at what buildings use energy for and where they're deriving that energy from, it becomes really critical to meeting our climate goals in this region. So every 4 years, the Department of Energy does this survey called the Residential Energy Consumption Survey, or the RECS, where they just do a slew of data on how residential buildings are using energy. And so one of the things that they look at is the breakdown of end uses in buildings. And if you look at the Midwest, what you find is that 72%, so the vast majority of energy use in residential buildings in this region, comes from two end uses: space heating, so your furnace or boiler that's serving a hot water radiator, whatever is keeping your home toasty in the winter. That's over half of the energy use by residential buildings in this region. And then another 17% is the water heaters. So that's a huge aspect of how these buildings use energy. And predominantly, they are getting that energy from fossil fuel combustion. Almost 80% of residential buildings in the Midwest use combustion as their main source of heat, mostly natural gas, but also a fair amount of propane or wood burning as well. So that means that the biggest bulk of our energy use is currently coming from fossil fuels that we burn on site right in our homes. And that means even as the electric grid cleans up, there's this huge aspect of building energy use consumption in the Midwest that isn't going to take advantage of that, because that's not where it gets its energy from. So that's, again, coming back to that idea of there's these 3 R's, there's these 3 aspects of building decarbonization, and you can't separate one from the other, right? You can't just do carbon-free electric generation and then you have this huge portion of the energy use of buildings that doesn't even use electricity right now. You got to do the electrification piece too. And you also got to make sure that when you're doing that, that you're making that as efficient as possible, so you're not causing undue energy burden or making it more difficult to provide enough carbon-free electricity. So beyond that just huge share of emissions and pollution that needs to be addressed, there's also a sense of urgency to addressing these ignored aspects of building decarbonization because of how long buildings last and how long the stuff that we use to make them usable lasts. So the American Institute of Architects estimates that around 80% of the buildings that we're going to have in 2050, which we know is kind of the end mark of when we need to be hitting net zero emissions to stave off the worst effects of climate change, they believe that 80% of those buildings are already standing or currently being built, right? So we know that we have to deal with our building stock here because it's either going to work for or against our climate goals. We also need to recognize that equipment in these buildings, well, maybe being replaced over that longer lifespan of the building as a whole, also lasts a long time. So the median lifespan of gas furnace or other piece of fossil fuel heating equipment for a building is just under 20 years. So we know that there's a good chance that any furnace or gas boiler that's getting installed in a building today is still going to be in operation once we hit 2050. So that means that either it's not going to be working in favor of those 2050 emissions goals that we know we have to hit, or we are committing ourselves to an unnecessary and probably costly retrofit before the end of that equipment's life. And even beyond that, if we think like, well, it'll probably only last 20 years, 2045 or something, we'll have one more crack at replacing this and we can electrify then. We at least need to make sure that the equipment that the buildings that we're constructing or doing retrofits on now are being designed to be electric ready, that they can accommodate these forms of equipment in the future, because the panel, the wiring, the shell of the building, that is probably for sure going to last 60 to 80 years, right? And again, it's much easier to do those upgrades and prepare for that future reality when you're building the building for the first time, or you're already tearing a bunch of it up, than it is going to be to do it many years down the line, right? It's always more effective to do it correctly the first time than it is to go back and do it as a retrofit after the fact. We have a fair amount of those retrofits that we already have to do, so there's a lot of this is like just not digging the hole any deeper. And just another way to maybe drive that point home for folks. So this is looking at 3 forms of heating for a typical 3-bedroom residential home in Minnesota, because Xcel Energy, the main utility up there, had some good publicly available data on emissions per kilowatt of electricity and where their goals were going to be in the future. So the red line is a high efficiency gas furnace. The green line is what we would want to see in most folks' homes, a high efficiency heat pump. And just for fun, I threw in kind of an old inefficient electric system as well. So electric resistance, think like a electric baseboard heater or something like that. So in 2005, which was the first reported year of this data, there was still a fair amount of a pretty high amount of coal and gas generation on the grid that was serving this home in Minnesota. So in that first year of operation, that high efficiency gas furnace actually had less emissions associated with it than an electric one was. But as we move closer to our current day, the reported levels of progress that electric utility made by 2019, what we see is that when you combine the progress made on the cleaning up the electric grid with the higher efficiency of the heat pump, that halfway through that unit's life, actually we had now hit that inflection point where the heat pump actually had less emissions associated with it. And then as we move forward to the emissions targets that that utility had set for the end of the decade in 2030, even a low efficiency electric system, because the grid has cleaned up so much, is going to produce less emissions. Obviously, the heat pump is way less and also easier on that home's household budget. And they're both going to move towards that zero emissions goal for the home as that utility starts meeting 100% renewable goals. Meanwhile, this furnace that is still in its useful life through most of this time span is going to, on average, keep pumping out the same amount of emissions every year. And I think that's really key for folks to understand that every time we install one of these gas appliances, that we're locking in a level of emissions, for the next 20 years that are going to be associated with that building. And it's not going to matter what else that utility does, because the equipment that serves that building is not going to take advantage of it. Beyond the climate, emissions and pollution aspect, there are also a whole host of other reasons why building decarbonization is important and why we feel we need to deliver this transition equitably to all communities. Not minor amongst those is the health co-benefits of building electrification and decarbonization. So we know, and it's a statistic that's been confirmed multiple times by different studies, that we spend around 90% of our time indoors. And that percentage probably creeps up when you're talking about more disadvantaged communities, folks with disabilities and things like that. So because we're spending so much of our time indoors, we know that the quality of our indoor air has a huge impact on our health. And we know that homes that are served by gas appliances, specifically gas cooking appliances being the main big one, because they're not as vented to the outside, those combustion fumes, that they have 50% to 4 times the concentration of indoor air pollutants, such as NO2, and that children in those homes are significantly more likely to develop asthma symptoms. And there's a whole host of other research coming on about other health detriments associated with having high levels of these pollutants in our homes. And in fact, we know it's not even just when they're on. The nature of how these appliances get installed, we're learning more all the time that they're probably leaking things like methane into our homes all the time, just by the nature of having those open appliances. So again, there's the critical climate and emissions issue, but there's also a critical health issue happening here as well that should be addressed by delivering decarbonization to our homes and workplaces in this region. And then finally, the energy burden and economic impact. And so right now, probably one of the barriers to building decarbonization being popularized across the region is that we've had historically pretty low natural gas prices and utility rates in this region for a long time, right? Especially compared to what it would cost to heat your home with an electric system, with the way that residential electric rates are currently being structured. And we're always sensitive to that as a coalition as well. We don't want to increase energy burden or negative economic impacts for at-risk communities as part of this transition. But we also feel strongly that that's changing, and changing very fast, right? So in 2022, Department of Energy was anticipating that residential heating prices were going to go up around 27% on average nationally for gas customers, and only 4% for predominantly all electric customers. And I know from digging into it for other conversations we've had on a state-by-state basis that In some of the states we work in, it was much higher than that projected 27% that those yearly average rates went up. So, and the reason for those increases are varied. You know, they include, you know, international disruption with Ukraine and things like that. But really, the key thing that drove that specifically in 2022, in 2022 was extreme cold weather events like the polar vortex, which meant that gas utilities had to meet a huge spike in demand very quickly, which was expensive for them. And then in subsequent years, those costs were being passed on to customers. And we're just recognizing that with climate change, those extreme cold events are probably not going to be, they're going to start becoming more of the norm. And so we know that it's very likely that gas prices are going to continue to increase. And they've always been historically much more volatile than electric prices. We don't see any reason for that to not continue as well. We also know that when that volatility hits, it doesn't hit all households equally. In that same report that was projecting those increases in cost, they were also mapping out like, okay, how is this going to affect energy burden or the percentage of a household income that goes to energy bills. And what they found was that for high income households, it was only going to increase that energy burden by 0.3%. But for low income households, it was 3% or a factor of 10 more impact for those low income households. So we know that this price volatility associated with dependence on fossil fuels to provide heating and other forms of energy to our homes is going to keep hitting our most vulnerable households the most. So that's kind of why buildings in general and all of the reasons for building decarbonization. And I mentioned before that this is really a critical Midwest issue as well. So part of that is just that the share of emissions that the Midwest provides the US in general is very high. We account for around a little over a quarter of the nation's overall CO2 emissions. If we were our own country, we would be number 5 in the world, right between Russia and Japan. And if we look at, you know, building specific emissions, like I said, we have this higher occurrence of homes being served by natural gas in the rest of the country. Remember, we said around 80% of homes have fossil fuel combustion as their main fuel source for heating. It's closer to 72% nationally for heating, and I think water heaters, it's around 50% nationally. So just way more dependent on fossil fuel for our building heating compared to the rest of the country. And then if you look at this heating degree days map, which is kind of a technical HVAC industry term, but the main thing to understand is the more heating degree days a region has, the longer and more intense its heating season is. So you'll see that the 2 census regions that make up the Midwest have the highest number of heating degree days compared to anywhere else in the country. So that lines up with that, you know, over half of our building energy use going to space heating, which is, again, isn't typical for the rest of the country necessarily. So really decarbonizing our buildings, super critical for the Midwest in a way that, you know, maybe isn't the number 1 item in other parts of the country. It is here. I'm going to pause there for a sec. Also want to talk about this idea of making this an equitable building decarbonization transition. We really believe that strongly here at the coalition. So the definition that our members arrived at for what equitable building decarbonization means is to remove the hazard of fossil fuel usage in buildings and facilitate access to carbon-free heating, water heating, and cooking, while prioritizing Black, Indigenous, people of color, or other intersectional identities, and empowering poor, low, and moderate income households and underserved communities with clean technologies and infrastructure, including equitable outcomes in who produces and who benefits from decarbonization, and leadership of enterprises and communities most impacted by the burdens of energy and environmental injustices. So getting into recognizing that idea of that we're starting from a level of inequity in this work. And I always say this is not like an exhaustive list of the statistics that pertain to the work that we're doing, but just to give folks a taste of the equity hole that we're trying to dig ourselves out of before we even talk about building decarbonization. But we know that the 8 states that we work on, and they average between 35 to 43 affordable rental units per 100 extremely low income renters. So we know just in general, most of our states are anywhere from a third to a half of the affordable housing that they really truly need to serve the needs of folks living in those states. And that's any form of housing, right? Not even transitioned or decarbonized housing. We also know that 28% of Midwest households experience energy insecurity, and this was from a 2015 study. So we know those numbers have been exacerbated in the last 3 to 4 years with the COVID-19 pandemic. So meaning energy insecurity, meaning difficulty being able to pay the energy bills for their homes, either because of high rates or highly inefficient homes or just low level of income. And in those 19%, so about 2/3 of those households, it was so severe that they were going so far as reducing or foregoing necessary food or medicine to be able to ensure that their homes remained heated or cooled as necessary to be livable. And we also know that these energy insecurity impacts are not felt equally along racial lines. At the height of the COVID-19 pandemic, Black or brown households 2 times as likely to experience a utility shutoff than their white peers. So recognizing some of that reality, we know that historically, when we have been making huge investments and transitions of the nature that we will need to achieve building decarbonization, that the reality has been that select groups have reaped most of the benefits from that transition, while other communities, were actively sacrificed to do that. Think about the electrification of a huge part of this region, in the 30s of even getting electricity in the first place. And where does the electricity get delivered? White communities. Where do the fossil fuel power plants and their pollution to provide that electricity get located? Black communities. So we know that this transition cannot be like that. These investments cannot be made like that. And we can't even settle for equality of the benefits and downsides of this transition being made equally, because we're digging out of these historical holes. And we need to make sure that all communities are actually getting the level of support that they need to overcome these barriers to a clean energy transition, or just removing those systemic barriers entirely. And yes, I see a question in the chat about the slides. We will make sure that we get those sent out to folks that registered. And again, we are recording today, so if you want to pick up the rest of this presentation later on, you'll be able to do that. Okay, so that's what we're shooting for. What are the challenges that we are trying to overcome? So first, there are a fair amount of challenges represented by the way that our utilities currently operate. I touched on a few of them before, but I'll get a little bit more into it now. One is that the way that different energy efficiency or rebate and incentive programs that utilities operate run, how they currently operate, right? So a lot of you may be familiar with things like, you need to put in a new air conditioner or something like that, and there's a rebate available from your local utility to put in a more energy efficient one. And most of those programs were mandated for the utilities to do by their states. And the reason for that mandate had more to do with reducing the need to build new power plants or gas infrastructure, things like that. It was way before decarbonization was even on a lot of folks' radar. So that means that there's a lot of old rules about how those operate that don't necessarily play nice with the goals that we have now. And one is around this idea of fuel switching. Most of these programs are designed to not allow folks to switch from electricity to natural gas or natural gas to electricity, right? They are designed to let you put in a better version of what you already have. So if you already have a gas furnace in your home, they will give you generous incentives to put in a higher efficiency gas furnace. But if you want to make the switch from a gas furnace to a heat pump, which instead of utilizing gas as its energy source is now going to use electricity, in most cases, those utility programs are not going to be a lot of help. So they're just not designed to foster electrification. And then even in things where that type of old style energy efficiency program might be helpful, doing things like weatherization or insulation upgrades or things like that, that would be fuel source neutral. They're also governed by cost effectiveness rules that really make it difficult to deliver benefits through those programs to different communities. So the utilities have to demonstrate that they're delivering X amount of savings per dollar spent on the program. And what that means is they are incentivized to do programs that they don't have to cover as much of the cost, right? So that's why you'll see a lot of programs that really work well for developers or high-income households where they don't need as much of the cost covered to move them to a different decision. But it also means that not enough of the costs are covered for lower income households or communities to really be of much help to them for making those home upgrades. And that's why I also say they're just not very holistic. They're not going to cover the other associated costs, like making a necessary home repair to accommodate new equipment or upgrading electrical wiring that might be necessary to put in a new high efficiency heat pump. Also touched on this a little bit as well, but the rate structure from most utilities, there's a real lack of all electric heating rates that are going to make those things attractive for folks. The way that they calculate out the different rate structures and things like that is still very stuck in this mode of when and why folks are using electricity. And until that changes, it is going to be difficult to help folks make this transition without exacerbating existing energy burden issues. There are also workforce challenges to building decarbonization. So there's a general shortage of skilled technicians and electricians that we know we need to do this work, or even just their like bread and butter work these days. If you've even struggled to get a heating and cooling contractor or an electrician out to your home to do something. And it's a very graying field as well. A lot of those experienced and skilled technicians are nearing retirement age without the investment and kind of bringing up that next generation having been made. So we're going to have to train up a lot of folks in that industry in a hurry. And then even the contractors that are already out there in the field, especially in this region where, again, 80% of our homes are not utilizing predominantly electric heating and cooling technology in their homes. They're utilizing gas. So that means that is the technology that these contractors are familiar with, that they're comfortable with, that they're confident if they install it in somebody's home, they're not going to get a call back in a month that somebody is unhappy with it. A lot of times they're operating on outdated information about what the state of heat pump technology is. I tell folks all the time, I graduated from engineering school in 2009. In my first jobs, my bosses would say, you don't spec heat pumps unless there's absolutely no way to run natural gas out to this project because once it gets into those cold winter temperatures, it's not going to work anymore. Now that was the case 20 some years ago. It's not the case anymore, but a lot of contractors have not gotten the memo on that or haven't heard that message enough to feel totally confident in going out and installing it. I'll also point out that there are major equity gaps in that workforce as well. This is possibly a way to solve two problems at once with that need to build up a workforce very quickly, that we can make sure that efforts to do that are targeted at communities that have been traditionally locked out. But if you look at studies of diversity in the clean energy field, compared to their overall share of the workforce, the representation of Black workers in these fields is around like a third of what it should be to be in line with their share of the total workforce. And if you dig deeper into those statistics, you'll also find that even Black or brown workers that get into those fields, they tend to kind of be pooled at the more entry level of those fields, and you don't see as many of them advancing into construction management or engineering and design or owning their own contractor groups as their white peers. And then just a whole host of other challenges that we know about and that we're trying to overcome as a coalition to help this region make this transition at the speed that we know we need to. One is split incentives between tenants and building owners, really make it difficult to deliver decarbonization benefits to renters. So what I mean by split incentives is this idea of if I'm a landlord that owns the building and I'm probably the one paying to make building upgrades to decarbonize it, but I'm not the one that's paying the utility bills or seeing those additional health and environment benefits because I don't actually live in the building. I'm not actually the one getting the monthly utility bill. I'm not motivated to go ahead and make those changes. So recognizing that the programs and policies that we've had in the past have not been sufficient to move those property owners to make the improvements that they need to equitably deliver this transition to their tenants. We have a number of states that politically are unfriendly to building decarbonization for a variety of reasons. So that both makes it difficult to advance new policies and programs at the state level. It also means that things that we try to do at the local level have that risk of a state government coming through and undoing that progress. So that's always a challenge that we are on guard for as a coalition. There's the technical challenge of balancing this need to do that electrification, that middle R piece of this, with concerns about grid capacity or how fast we can convert the electric system to that carbon-free generation source. And that's again why we come back to that, having three aspects of energy efficiency and recognizing that they are all equally important. That energy efficiency piece is key to mitigating some of those grid concerns, to keeping the amount of clean electricity that we need to be providing and building to an absolute minimum so that we are able to do it. We can't just be slapping heat pumps in inefficient and leaky buildings and hoping for the best. That's not doing anybody any favors. There's also the challenge of, again, I said, those 80% of our buildings that we're going to have in 2050 that are already built or already here. Ask anybody that works in construction or architecture or engineering. Existing building retrofit projects are the worst. They are always complicated. They are always messy, and inherently that makes them very expensive. Which makes it tough to get the level of resources we need to make that transition. And that's also why it's super key to make sure that as much of our new construction as we can going forward is already built, decarbonized, so that we can stop digging that hole any deeper. And then kind of the last one, maybe the little bit funnier one, is that most of these measures happen inside the building. They're hard to see. They're not like super sexy or generate a bunch of buzz or fanfare, and so that makes it hard to get people motivated on it, right? Compared to a big new solar development or rooftop solar array that somebody can drive by and see and think, oh, that's great. This is great for the community, and it really gets folks excited. An extra inch of insulation in the wall or a heat pump that's kind of like tucked behind in the alley or something like that just isn't going to generate that level of excitement. So that's why we always need more coalition members and advocates out there generating that excitement so that we can get moving on all of this. So again, thanks for attending this training. This is really meant to be a high-level overview. We could get into all of these topics much more deeply given more time. I hope that if some of you are not already coalition members, but we're interested in what you hear today, if you want to get more involved, you can visit midwestdecarb.org. You'll find information about registering for other upcoming trainings there. You'll see the information about attending an orientation to become a member and learn more about our different working groups and ways that coalition members are working together to advance this. So encourage folks to go and check that out. And yeah, I think that was it for our main training today, but we do still have time available for me to stick around. So if folks had any questions, if you want to drop them in the chat or the Q&A, I'm happy to touch on anything that folks had questions on.